Okay, so let's solve this one. We have y equals cube root of 2 raised to secant x plus hyperbolic tangent squared of 1 minus x all over inverse cosecant of ln 2 minus x. In this problem, we need to find dy dx, but we need to choose which method will we use. We can choose log diff here, but for the numerator in the radicand, there's a sum. And applying loss of logarithm in there won't make those sum be separated from each other. Hence, maybe direct differentiation is as long or as complicated as log diff will offer, but you can try the other one. Whatever I will do here, please try the other solution. So in here, before differentiating, I need to transform this first into a power. Say 2 raised to secant x plus tang squared of 1 minus x all over inverse cosecant of ln 2 minus x raised to positive 1/3. Am I correct? With that, I can use power rule, then chain rule will do the rest. Hence, dy dx is equal to power rule, 1/3 will go down in front of the base, and we need to copy the base. That's a long base. All over inverse cosecant, just bear with this. Yeah. Then raise it to 1/3 minus 1. What's 1/3 minus 1? That's negative 2/3. Then chain rule. We need to multiply this by the derivative of the base, which is in this case a fraction. Hence, we need to use quotient rule. Low d high minus high d low all over low squared. Hence, we have low d high, low. We copy what's in the denominator times the derivative of the numerator is, we have two terms here. The derivative of 2 raised to secant x is 2 raised to secant x ln 2. Am I correct? Multiplied to, by chain rule, derivative of secant x. And that is secant x tangent x. Very good. Then plus, what's the derivative of the second term? Tang squared of 1 minus x. Yeah, we use product power rule first. We bring down 2. Then we subtract 1 from the power of tang of 1 minus x multiplied to the derivative of tang. What's the derivative of, recall? What is the derivative of the hyperbolic tangent? It is just the hyperbolic secant squared. Okay, so this derivative is just equal to the hyperbolic secant squared of 1 minus x. Then lastly, let's go to the innermost function. We multiply it by the derivative of 1 minus x is negative 1. That's for the low de high. Then let's have minus high de low. Now we copy high, copy the numerator, plus tang squared of 1 minus x. Copy that. High times the derivative of the denominator is, recall, what's the derivative of inverse cosecant? We have a negative 1 over x square root of x squared minus 1. So this is multiplied by negative 1 over, we copy what's inside the inverse cosecant, and that is ln 2 minus x. Then let's take the square root of the square of what's inside, that's ln 2 minus x squared, then minus 1. Okay, I'll transfer this negative 1 here. multiplied by the derivative of what's inside cosecant. What's the derivative of ln 2? 0, that's a constant. What's the derivative of negative x? That's negative 1 as well. And that's for low d high minus high d low. So the last thing we need to do is we divide this by, we divide this by, let's fix the parenthesis. Okay, we divide this by the square of the denominator. Okay, so please don't distribute that power or don't multiply negative 1 and 2 because that power of inverse cosecant is a built-in notation for an inverse of a function, or in this case an inverse of a trigonometric function. Actually, I'm okay here, but if you are quite OC, you can still multiply negative 1 and negative 1 and put this in the numerator. Then you can put this negative 1 in front of 2 tanh 1 minus x secant hyperbolic secant squared. What else? That's pretty much of what is okay to me now. So that's it. Okay, now let's have this example. We have here inverse sine of x minus y equals the inverse tanh of the fourth root of y. Well, this tells us that we need to find dy dx through implicit differentiation. Recall, the derivative of inverse sine is just a 1 over square root of 1 minus x squared. And the derivative of inverse tanh of x is just 1 over 1 minus x squared. Almost the same, except for a radical sign. Okay? Now let's try to find dy dx. So first, for the left-hand side, we have here the derivative of the inverse sine is 1 over the square root of 1 minus the square of what's inside. Am I correct? Multiplied with the derivative of x minus y. And we know that that is 1 minus the derivative of y with respect to x is y prime. Okay? It is equal to the derivative of the inverse hyperbolic tangent. From here, we know that that is 1 over 1 minus the square of what's inside. Am I correct? Then multiplied by the derivative of what's inside. So what's inside is a fourth root of y, and its derivative is, if you can't imagine it right away, you can transform this. Even if it's on your mind, you can transform this as y raised to 1/4. So its derivative is 1/4 times y raised to negative 3 over 4. Do you follow? Then lastly, since y is a function of x, we multiply it by the derivative of the innermost one, which is y prime. Hence, again, our task is to isolate y prime. And I guess that's an easy peasy thing for us. What we do next is we distribute this guys here, then isolate y prime. We have 1 over square root of 1 minus x minus y squared minus y prime over square root of 1 minus quantity x minus y squared equals 1/4 times, sorry, can I bring this down now so that we don't have any negative powers here. We have 1/4 y raised to positive 3/4. Will that be okay? Okay lang? And then, multiplied with 1 over 1 minus. Since this is just an easy thing to simplify, this is just the square root of y. So, pwede natin i-simplify times y prime. Okay? And now, we're almost done. Let's transfer this to the other side, but let's put it in the left-hand side. So, we have here 1 over 4y raised to 3/4 times 1 over 1 minus square root of y prime, plus, let's move this one to the other side, y prime over square root of 1 minus quantity x minus y squared, do you follow? Equals, then this side is just to be copied, square root of 1 minus x minus y quantity squared. Okay, then let's just put this in front. Say, we delete this one, we delete this one, and we factor it out of each terms. So we have y prime. And what's the last thing to do? We need to divide both sides by this factor. So copy that. Okay, that's a long fraction, but this will just cancel out. So we're left with verify that mentally, I'm kidding, that this is equal to y prime. So y prime is equal to 4y raised to 3/4 times 1 minus square root of y times square root of 1 minus quantity x minus y squared all over square root of 1 minus quantity x minus y squared times 1 minus square root of y plus square root of 1 minus quantity x minus y squared. Again, am I correct? Please verify that this is true. Okay, apparently this will cancel out. So you'll have a 4y raised to 3/4 times 1 minus square root of y all over 1 minus square root of y plus square root of 1 minus quantity x minus y quantity squared. So that's it. Okay.